Welcome to day 16 of our high level design course. In this session, we will dive into breaking down components and services. Let's explore how to effectively decompose complex systems into manageable, scalable parts and define clear service boundaries. Here's our agenda for today. First, we will discuss how to decompose large systems into smaller, more manageable components. Then we will explore how to identify service boundaries. Finally, we will cover tools and techniques that help us in the decomposition process and in defining boundaries. When breaking down a large system, functional decomposition is a great starting point. We break the system into subcomponents based on their functionality. This makes the system easier to understand and work on. Next, we follow responsibility driven design where each component is given a clear singular responsibility. By doing this, we keep our components focused and manageable. Lastly, we need to balance the size and scope of each component. If a component is too large, it becomes too complex to maintain. If it's too small, it might create unnecessary overhead. Core components are central to the operation of the system. For example, in an e-commerce platform, payment processing, order management, and user authentication are core components. Peripheral components like logging and analytics support the system but aren't critical to its main function. When designing, prioritize the core components and focus on them first to define the overall structure of the system. Service boundaries define where one service ends and another begins. This is crucial for modularity. By clearly defining service boundaries, we ensure that different parts of the system can operate independently and scale as needed. For instance, in an e-commerce system, the payment service might interact with inventory, but these separate services that should be loosely coupled. Microservices architecture is a common approach to defining service boundaries. Each microservice encapsulates a distinct business capacity, making it easier to scale and maintain. It's important to avoid overlapping services to minimize tight coupling. By having clearly defined service boundaries, we reduce complexity and increase flexibility in scaling and development. In domain-driven design, we use bound contexts to define service boundaries. A bounded context represents a specific domain within the system where a particular model applies. For example, the customer in the user service might be represented differently than the customer in the billing service. This allows us to model complex business domains effectively while maintaining clarity and avoiding confusion. We also need to distinguish between external and internal boundaries. External boundaries are points where our system interacts with outside systems like third-party APIs or databases. Internal boundaries define interactions between internal services such as between the front end and back end or between different microservices. Once we have broken down the system into components, it's essential to define how they communicate. This is done through well-defined communication interfaces, usually in the form of APIs. It's important to design these APIs thoughtfully, ensuring backward compatibility and versioning to prevent issues as the system evolves. We also need to map out service dependencies to identify potential bottlenecks or scaling issues. Service dependency mapping helps us understand how different services are interconnected. By defining these dependencies, we can make sure that critical services don't fail when others are down. For example, if the payment service depends on the inventory service, we need to ensure that the payment service can handle failures in inventory gracefully without causing major disruptions. Let's take an example of a service boundary in an e-commerce system. We might have a user service that handles authentication and profile management. A separate product service would manage the product catalog, while an order service is responsible for order processing. These services should interact with one another th- through clearly defined interfaces such as APIs or event driven systems. To help with decomposition and defining boundaries, we use different architectural styles and tools. Microservices, event driven architectures, and modular monoliths are some of the styles we can apply based on the complexity. Tools like UML and C4 models that help visualize the system structure while maintaining cohesion within components and reducing coupling between them. In dynamic systems, we use service discovery tools like Consul, Eureka, and Kubernetes. These tools help manage service boundaries in environments where services are constantly being added, removed, or scaled. Service discovery ensures that services can find and communicate with each other without manual configuration, making the system more flexible and adaptable. In conclusion, breaking down components and defining service boundaries is critical for creating scalable, maintainable, and flexible systems. Focus on clear responsibilities for each component, reduce dependencies between services, and design APIs for smooth communication. By following these principles, we can build systems that are easy to scale and evolve. Thank you for your attention. If you have any questions or need clarification, now is the time to ask. I would be happy to discuss any points further.